Hey friends, what's up? I'm Shantan, MC Reader Mathematics. Let's mathematics. So today in this video, I'm going to discuss about numbers. From the watch to the calendars, from the money to the passbook. Everywhere there is a number. Either fraction or real, complex, there is no complex number actually. So without number, there was no calculation at all. No mathematics, no physics. So today we're going to discuss about the classification and the analysis of numbers. Let's get started. The natural numbers are denoted by n, and if we say that small n belongs to natural numbers, the set of the natural numbers, then if we impose that minus where the n belongs to natural number, which are the natural numbers, that is 1, 2, 3, 4, like this and so on. And if we impose that minus n, that is minus 1, minus 2, minus 3 and so on, and the 0 term, then all total, that is 0, minus 1, minus 2, minus 3, like this, and 1, 2, 3 and like this and so on. This will be called the integer, that is z. The set of all integers which is denoted by z. This is the set of all integers. And if we add the fractions with these integers, that is fractions mean suppose that 1.5, 2.7 and so many are there. So if we add the fractions with this z, then we will get the rational number. Which are the rational numbers? The rational numbers are those which can be written in the form that p by q, where this p and q are both integers, whereas that q cannot be 0. Q cannot be 0, but p can be, this is the set of all integers, then p can be any of this, but q can be without 0 and can be any of this minus or plus positive integer. And now I should mention that here z can be classified in this way, that is sometimes in books you may see that there is written as z plus. Z plus means actually here 1, 2, 3 and so on, this part. Z minus implies that minus 1, minus 2, minus 3 and so on, that negative to the infinity to the that part. And z is actually 0 union z plus union z minus. Okay. And adding that integer to the fraction, we will get that rational number. And now as I said that the rational numbers are always in this form, that p by q, whereas this p and q both are integer, but the denominator part, that is q, cannot be 0 other than any of the integers. Okay, these are called the rational numbers. And which are the rational numbers? Those numbers which are integers or fraction but cannot be write in this form p by q. Okay, whereas the p and q are both two integers. Okay, now all these terms belongs to the real number, which is denoted by r. Okay, the real number contains all of these sets, that is the natural number. The natural number is actually contained in z, that is the natural number is a section of subset of the integer, and thus the integers actually a subset of the rational number, and the rational number is a subset of real number. And now the real number is actually a subset of complex number, whereas the complex identity, that is small I, which is a complex identity element, actually this I satisfied by this equation, I square equals to minus 1. This is called the imaginary I. Okay, and now when we extend the real field, we will get that complex field. And now we will study what is a complex number. This is a diagram, whereas we chose the x-axis as the real line and the y-axis, that is the vertical line, as the imaginary axis. Okay, and now we take a point a comma b in this plane, and we take the a along the real line and b along the complex line. Now then we get that point a comma b. This is a ordered pair, and this is represented by complex number z that is a plus ib. In this figure, the distance between the origin to the point, that is the smaller is actually modulus of z. Taking that modulus, a complex number that is in the form a plus I, means we cannot say that 2 plus 3i or 2 plus 5i which is greater or which is less. This is the main difference between the real number and the complex number. Two real numbers, we can say that which is greater and which is less. But in the complex number, we can't say that. Okay. Now there is another thing that is denoted by theta, that is called mz or arc z, that is argument of z, which is written like this. The theta lies here, and we all know that the tangent of this theta will be perpendicular by base, and the perpendicular is b and the base is a. So tan theta equals to b by a, which implies that theta equals to tan inverse of b by a. Now this theta is called the amplitude of z or argument of z. Now this theta varies somewhere. In first quadrant, this theta lies between 0 less theta less pi by 2. But in the second quadrant, this theta lies between pi by 2 less theta less pi. And in the third, this theta lies between minus pi less theta less minus pi by 2, because here we take the angle in anti-clockwise actually. So this angle will be minus pi and this angle will be minus pi by 2. So this region will be denoted as like this. And whenever theta is in the fourth quadrant, then the region is minus pi less theta less 0. And this diagram also called the Argand diagram, which is named after John Robert Argand. So this is the classification of numbers. So we see that complex number actually accord all these numbers, whereas this is a complex number and this is called the real part and this will be called the imaginary part. In a complex number the real part is 0, then it will be called a purely imaginary number. So this was the class, guys, and hope you guys have enjoyed this class. If you have not yet subscribed to my channel, please subscribe to it, press the bell icon to get notified. Stay tuned. Thanks for watching. Jai Hind, Vande Mataram.